Ever wonder how a self-driving car just slams on the brakes in a split second? Or how a smart factory can spot a tiny microscopic flaw on a product zipping down the assembly line? Well, the answer to both is a technology that's quietly reshaping our entire world: edge computing. Now, I know it sounds super complex, but the idea is actually pretty simple. It's all about bringing intelligence closer to where things are actually happening. So let's dive in and break down how it works and why it's becoming so incredibly important.
All right, here's how we're going to tackle this. First, we'll look at the cloud's big data problem, the reason we need the edge in the first place. Then we'll actually define what edge computing is and take a tour of its architecture. After that, we'll see it in action in the real world. And finally, we'll cover some of the hurdles still on the horizon.
Okay, so to really get why edge computing is such a big deal, we first have to understand the problem it's trying to solve. And that problem has to do with the way we've been doing things for years now, with the cloud. It all boils down to one single thing: just an unbelievable explosion of data.
Get this, 175 zettabytes. That is a 175 with 21 zeros after it. I mean, that number is so big, it's hard to even wrap your head around. To try and put that in perspective, if you were to store all that data on Blu-ray discs, the stack of discs would reach to the moon and back 23 times. Yeah, this tidal wave of data coming from our phones, our cars, our factories, it's starting to totally overwhelm our current cloud infrastructure.
So that brings up a really big question, right? Can we really keep sending every single byte of data from every single device to some faraway centralized cloud to be processed? You know, for things that need instant decisions, like that self-driving car or maybe even remote surgery, the answer is a hard no. The delay, what we call latency, is just too long. And honestly, the cost of sending all that data back and forth, it's just not sustainable.
This is exactly why we need a totally new approach. What if, instead of sending all that data on a long journey to a distant cloud, what if we brought the computing power closer to the data itself? Well, that's the big idea, the fundamental shift behind edge computing.
And here it is, our key definition. It's a distributed model, which is just a fancy way of saying it's not all stuck in one place. The whole point is to put the processing power right where the data is being born, on the factory floor, inside your car, or at your local retail store. The goal here is super simple: make things faster and more efficient.
Now, this is a really important point to get. The edge is not here to replace the cloud. Think of them more like partners. The cloud is amazing at huge, long-term jobs, like training massive AI models on gigantic datasets. The edge, on the other hand, is all about the here and now. It uses those models that the cloud trained to make instant decisions out in the real world. That process is called AI inference.
So, what does this new setup actually look like? How is it built? Well, it's usually broken down into 3 distinct layers, and each one has a very specific job to do.
Everything starts at the very bottom, with what we call the things layer. These are all the gadgets and devices that are actually creating the data in the first place. We're talking about the sensors in a self-driving car, the security cameras in a smart city, or the industrial robots that run a modern factory. Those robots are often controlled by these rugged little computers called programmable logic controllers, or PLCs. They're basically the industrial brains of the whole operation.
Okay, next up is the edge layer. This is where the magic really happens. This is the local brain. It acts like a mediator, gathering up all that raw data from the things layer. But here's the key. Instead of just blindly forwarding everything, it filters it, it processes it, and it analyzes it right there on the spot. Only the really important stuff, the key insights, get sent up to the cloud.
And finally, at the very top, we have the cloud layer. This is the central command center we're all familiar with. It's got nearly unlimited resources, but now, thanks to the edge, it's freed up to do what it does best. Things like long-term data storage, running complex analytics across an entire company, and of course, training the next generation of powerful AI models. Now, it's super important to realize that these edge devices have to be tough. I mean, really tough. They're not sitting in some nice climate-controlled data center. They're out in the real world. So they're built to be fanless to keep dust and gunk out, they're shock-resistant to handle vibrations on a factory floor, and they can operate in seriously extreme temperatures.
So to handle all these complex AI tasks right on the device itself, edge computers use these specialized chips called accelerators. You've got GPUs, which are awesome for video because their thousands of cores can process tons of data streams at once. VPUs are vision processing units. They're designed for low-power computer vision tasks. FPGAs are super cool because you can customize them for very specific jobs, making them incredibly flexible.
And then you have NPUs, or neural processing units, which are built from the ground up to run AI models as efficiently as possible.
Okay, so we've covered the what and the how. That's great. But now let's get to the really exciting part, the why. How is this technology actually being used out in the real world to completely change the way things work?
Well, it really comes down to 4 key advantages. First, you get incredibly low latency for those real-time responses, like a self-driving car braking instantly. Second, you save a ton of money on bandwidth because you're filtering data locally and only sending what's important. Third, you get way better reliability, so a factory can keep its crucial safety systems running even if the internet goes down. And fourth, and this one is huge, you get enhanced privacy because sensitive data can be processed right where it's collected instead of being sent halfway across the world.
And make no mistake, this isn't some niche, futuristic technology. This is a massive shift that's happening right now. It's predicted that by 2025, a whopping 3/4 of all data generated by businesses will be processed outside of the traditional cloud, right at the edge.
But, like any new frontier, this one comes with its own set of challenges. Edge computing is incredibly powerful, for sure, but it's not exactly simple to roll out and manage.
So, what are the biggest roadblocks? Well, first off, security. When you have thousands of devices out in the real world, you have thousands of new potential points of attack. Then there's complexity. Just trying to manage all these different devices can be an absolute nightmare. Power is also a real concern, especially for small battery-operated devices. And finally, making sure that all your data is consistent and synchronized across this huge network, well, that's a major technical headache.
So, if there's one thing you take away from all of this, let it be this. The future isn't about the edge versus the cloud. It's edge and cloud. They work together in this incredibly powerful partnership where the edge handles all the real-time, immediate tasks, and the cloud provides that long-term, big-picture intelligence. So what we're seeing is the beginning of a truly major shift. We're moving computing power out of these distant, anonymous data centers and weaving it directly into the world around us. This is going to unlock some absolutely incredible new possibilities, from smarter cities to more personalized healthcare. But, it also brings up some really important questions about privacy, about security, and about control. As this intelligence literally moves from the cloud into our lives, the real question is, what will we choose to do with it?